Hello guys, welcome back to this channel. So today we are going to learn about sedimentation under the subject of environmental engineering 1. So guys, hope you all are safe at your home. So in today's lecture, whatever you have doubts, so please put it into the chat box, and one thing you must clear that please ask doubt based on today's lecture, that is on sedimentation. So in last 15 minutes I will clear your doubts. Okay guys? Yeah. So first we are learn what is sedimentation. So as you all of know, sedimentation is very first step or very initial stage in water treatment plant. So again, depends on its requirement, we are providing two types of sedimentation unit, a primary sedimentation and secondary sedimentation. Again, there are different types of sedimentation, depends on which quality of water you will get. So basis on that demand, you will apply the treatment, the specific treatment. So let's we see what is sedimentation. So as you can see in this flow chart, so as I told earlier, sedimentation is a very first step in water treatment plant. So your primary treatment is start with first is the sedimentation tank, and the location of sedimentation tank in your water treatment plant is after the source of water has been coagulated and flocculated, it is ready for sedimentation. So this mentioned statement is based, it's suitable for the secondary sedimentation tank. So as I told that there are two types of sedimentation, first is primary and second is secondary. So generally the primary sedimentation we are applying before the secondary treatment, that is initially we have to settle down all the settleable particles which will get obstruct into the further process. So that all particles, settleable particles, solid particles, we are settling down in primary sedimentation. And after secondary treatment, that is after coagulation and flocculation, we are providing the secondary sedimentation to settle down the floc form that is formed during the coagulation flocculation process. So let's we see what is the mechanism and what is exactly the sedimentation process is based on. So what is sedimentation? Sedimentation is water treatment process, or you can say it as it is a primary water treatment process during which the water has little or no movement and suspended solid sink to the bottom under the force of gravity. So this is the very important keywords, that in sedimentation the gravitational force is influencing factor or most important parameters. So overall the sedimentation process is based on your gravitational flow. So all the particles are settled down by the force of gravity and forms a sediment at the bottom of the tank, and this process is called as sedimentation. So as you can see in these three stages of sedimentation, in first diagram the water is turbid, so water is mixed, that is raw sewage. So as I described in this description that we are providing a stagnant water, that means there is zero velocity for this water. So basically we are stored this whole water into a stagnant position or into a container, rectangular container, as we that container we called it as sedimentation tank. So because of we are reducing its velocity, the settleable particles are settled down by the force of gravity, and that settleable particle or settled down particle we are called it as sludge or sediments. So that sediments we are removing after the process is over, and clean water is coming out through this outlet and we are collected. So this is the on-field sedimentation basins. As you can see, these are the rectangular cells. There are number of rectangular cells are provided, in that they are providing a sufficient duration or detention time. So detention time is nothing but the water is detained or stagnant throughout this sedimentation process, and by the force of gravity all the sediments or settleable particles are settled down at the bottom of the tank. So what are the objectives and use of sedimentation? Why we are providing this sedimentation technique? And what will be happen if we are not providing this sedimentation at the beginning of water treatment process? So objectives are, first and important objectives is to separate the solids from liquid using the force of gravity. So gravitational force is important factor. In sedimentation, only suspended solids we are represented by SS, capital SS. So basically we are removing the suspended solids from the treated from the effluent water. So what is the use of sedimentation? The sedimentation is used in water and wastewater treatment. So every water and wastewater treatment, this unit is compulsory, sedimentation basins. What are the applications or what are the use in other forms? The settling of coagulated and flocculated water prior to the filtration. So that I have told in earlier or in initial slide that, so that kind of sedimentation is, we are called it as secondary sedimentation. So what exactly happening in coagulation and flocculation is, in primary sedimentation, we are removing all the bigger size particle whose specific gravity is greater than specific gravity of water, right? So because of its heavy weight, that particles are automatically settled down. But those particles who are dissolved in water, so that particles we cannot remove by the force of gravity. So all that particles that comes to the next process, that is secondary sedimentation process or secondary treatment. So what is secondary treatment? Coagulation and flocculation. So basically coagulation and flocculation treatment we are providing for removing of the dissolved particles that we cannot remove in primary sedimentation tank. So what we are doing in that coagulation flocculation process? So we are adding some amount of chemicals in that coagulation flocculation chamber and we are mixing it at very higher speed. So because of that, all the dissolved particles present in that water which are collected to each other or agglomerated to each other, and there will be the formation of floc. Floc means is the cloudy structure. It is the heavy particle. So basically in coagulation flocculation process, we are converting the small dissolved particles into the bigger size of particles. So that floc formation we will be removed in the secondary sedimentation process. So as you all of know, sedimentation is based on the gravitational force. And when that gravitational force works, only when the size or the weight of particles is greater than the density of water, right? So ultimately in coagulation flocculation, the weight of particle is increased because of the floc formation, and that heavy weight or bulky weight is settled down in secondary sedimentation tank by the force of gravity. So that is the application, that is settling of coagulated and flocculated water prior to the filtration. The next is settling of coagulated and flocculated. Okay, the point is repeated. The settling of treated water in an iron and manganese removal plant. We are also provide this treatment in the heavy metal removal treatment to settle down the heavy metal particles, as obviously that are inorganic material, so its weight is greater than the weight of density of the water, and that heavy metals are automatically settled down in sedimentation process. So what is the principle based on the sedimentation? Sedimentation is based on which principle? The suspended solids present in water having the specific gravity greater than that of the water tends to settle down by gravity as soon as the turbulence is retarded by offering storage. So there are two important factors. First is the gravitational force, and second is we are retarding the turbulence. That means we are providing a sufficient detent time and we are reducing the velocity so that water will get in stagnant nature, and because of that the gravitational force work. So inorganic suspended solids having the specific gravity above 2.65 and organic suspended solids having the specific gravity above 1, that is greater than the specific gravity of water, that all particles were settling down in the sedimentation process. So what is the principle? The sedimentation based on which principle? There are two important keywords. First is the gravitational force and second one is the specific gravity. So it is based on the specific gravity of particle. The particles whose specific gravity is greater than 1 or the greater than water, all that particle will settle down in sedimentation. The particles having the specific gravity about 1.20 or so readily settle down at the bottom of tank, but it is difficult to cause the settlement of lighter particles. Lighter particle means the particles whose specific gravity is less than 1. So that particle we cannot be settled in primary sedimentation tank. So reason you know, because its specific gravity is less, that particles is either in dissolved state or in floating onto the surface of water. So these phenomena of settling down of particles at the bottom of sedimentation tank is known as hydraulic subsidence, and every particle has its own hydraulic settling value which will cause its hydraulic subsidence. That phenomena of settling down the particles is known as hydraulic subsidence, and each particle, so there are different types of particle present in water, right? So every particles has different hydraulic value. So based on its hydraulic value, the particles will get settled down. So the basins in which the flow is retarded is called as sedimentation basin, and the theoretical average time for which the water is detained in the sedimentation tank is called as detention time. So these some of the design parameters which we are using while the time of design of sedimentation tank: the detention period, the sedimentation basins, and the hydraulic subsidence. So again, as I told, there are different types of particles, right? So based on that particles, there are classification is done of sedimentation. So there are different types of sedimentation. So first is plain sedimentation, and second one is coagulated aided chemical type of sedimentation. So plain sedimentation is simply the settle down the particles by the force of gravity. So sometimes the primary sedimentation is called it as plain sedimentation. So in plain sedimentation, it is the process of settling down of solids and impurities in raw water to the bottom of the sedimentation basin by natural force alone. No chemical is added. So without adding chemical, sedimentation takes place. That sedimentation is called as plain sedimentation. So this method is very cheaper and mostly used in all filtration and purification system of water. And second one is the sedimentation by using clarifier and contact. That means in this method the chemicals are mixed in the water, and that water is rotated vigorously by the help of pumps for period of 2 to 3 hours per day. So per day we are adding some chemicals into that sedimentation basin, and all this water is vigorously rotated for the thoroughly mixing of all the chemicals. And the suspended solids are settled down in the bottom of reservoir tank. And last type is chemically assisted or chemically aided sedimentation or clarification. So as I already explained the process of coagulation and flocculation, right? So that kind of sedimentation tank we are providing after the secondary treatment. That is after the coagulation and flocculation treatment to settle down all this formation of fog, that heavy particle, that all fog material we will get settled down in secondary sedimentation. So this is the process in which the chemicals are added to the water and thorough mixing have done, and the suspended solid and other impurities are stick together and form the flock. So that flock we will settle down at the bottom of secondary sedimentation basin. So in general, the most used process is chemically assisted horizontal sedimentation, and following assumptions are based on. So there are again depends on the direction of flow. The horizontal sedimentation means the direction of flow is horizontal in nature. So we are providing the inlet and outlet arrangement in such a way that the flow is passed in horizontal nature. So what are the assumptions? So water generally in horizontal flow sedimentation basin, the water generally flows through a tank as an irregular flow. Thus, the intention of sedimentation is to create the condition in which the flow is uniform as for long enough period. So basically, we are providing a sufficient detention time to permit the maximum particle amount of flow to be settled down at the bottom of tank. So next important is what are the influencing parameter of sedimentation process. So there are different influencing parameter. So again, it is not a so easy process. So all the sedimentation mechanism is based on the size of particle, the shape of particle, the hydraulic resistance of particles, the velocity of particles. So all are the influencing factors. So first is size, shape and weight of particle. So for example, as I told many times that the particles whose specific gravity is greater than 1, only those particles we will settle down in sedimentation process. But the particles whose specific gravity is less than 1, that particles are cannot be settled in sedimentation. So that are the influencing factor, that is size, shape and weight of particle. Then the viscosity and temperature of particle or water. That means, as you know, the relation of temperature and the settling mechanism. As temperature increases, rise in temperature, the more the particles will settle down. So both the parameters are directly proportional to each other. As temperature decreases, less the particles will settle down. As temperature increases, more the particles will settle down. And again, the temperature is inversely proportional to the viscosity. Higher the temperature, less will be the viscous fluid, viscosity of fluid, and lower the temperature, higher will be the viscous fluid. The third parameter is detention period. More the detention time, more particles will settle down. Next is effective depth of tank. So this depth we are calculated after the designing of sedimentation tank. Then area of sedimentation tank. Surface overflow rate, that is the flow through which the particles will flow, or the velocity of flow. The surface overflow rate is nothing but, in short, the velocity of flow. The velocity of flow and the outlet design, inlet and outlet arrangement. So all that factors are the influencing factor of sedimentation process. Then the types of sedimentation basins. So again, depends on its types, we are designing separately. So depends on its types. There are two types, the rectangular sedimentation and circular sedimentation tank. So if we will get time, so we will also see some of the examples or problems based on the design of sedimentation tank. So sedimentation tank may functions either intermittent or continuously. The intermittent type tank are those which store the water for the certain period and keep it on the completely rest. And in continuous type tank, the flow velocity is only reduced and water is not brought to complete rest. So in intermittent type, water is under complete rest condition. But in continuous type, the main parameter we have to control is velocity of flow. So by reducing velocity, the flow will goes continuously. Then the sedimentation tank or basins may be either circular or rectangular, depends on its shape. So long narrow rectangular tanks with horizontal flow are generally preferred to the circular tank of the radial or spiral flow. So whenever we are go for the rectangular tank, we are following the flow of direction is horizontal in nature, and whenever we are go for the circular sedimentation tank, then the flow is either spiral or radial. So let's we see the rectangular sedimentation basins. The rectangular basins are the simplest design, allowing water to flow horizontally through a long tank. So basically its length will be a long. This type of basin is usually found in large scale water treatment plant. The rectangular basins have a variety of advantages such as the predictability, cost effectiveness and low maintenance. They are the least likely to short circuit, especially if the length is at least twice the width. So because we are maintaining the longer length of sedimentation tank, the short circuit problem will get reduced. What is short circuiting? Suppose we are not maintaining the proper length, then suppose because of the fluctuation of flow or varying the velocities, there will be the possibility or chance to disturb the water, and there will be the possibility of formation of turbulence. So that turbulence occurs because of the disturbing velocity. That mechanism is called as short circuiting. So because we are maintaining the large length, that problem will get reduced. The inlet and outlet arrangement of rectangular basins are shown as in next slide. And a disadvantage of rectangular basin is the large extent of land area is required. So that is only one the disadvantage in considering the cost. So otherwise this rectangular sedimentation basins are more effective, cost effective technique. So this is the typical diagram of rectangular sedimentation tank with the horizontal flow. So as you can see the inlet and outlet arrangement. So outlet is always kept or placed above the level of inlet, so that all the settleable particles are settled down, and the clean water we can collect it from through this outlet chamber. And before that outlet arrangement we are providing some baffle arrangement of weir, so that the remaining particles, the particles that are strike to this plate, and by the force of gravity it will be settled down, and all this clean water we will get discharged through this outlet pipe. So later on we are also going to see what are the different zones in sedimentation tank. So this diagram is I added here because of you know how its inlet and outlet arrangement. So next type is circular sedimentation basin. The circular sedimentation basins with the horizontal flow are often known as clarifier. So generally, whenever the term is comes as the circular sedimentation, so whenever the problem is asked based on this design of circular sedimentation, they are using the term clarifier. Clarifier means the circular sedimentation. This type of basin faces short circuiting problem, so that we are not facing in rectangular sedimentation type. Below figure shows the inlet and outlet arrangement of circular sedimentation. What is the difference between rectangular and circular sedimentation? So as you can see, actually this is the zoom cross section of this figure. So this is the central vertical placed pipe. So all this water is coming out from this centrally placed vertical pipe, and flow is then distributed throughout the peripheral area of circular tank. And inlet and outlet is nothing but the peripheral area, through this peripheral area outlet. So this is the on-field diagram of clarifier or circular sedimentation tank. So again, these are some important considerations that we have considered while the designing of sedimentation basins. So the settling of particles from the suspension depends on that are nothing but the characteristics of particles. So there are two types of particle. One is discrete particle and second one is flocculating particle. So what is discrete particles? The particles whose size, shape and specific gravity do not change with time. That means they are not influencing parameter with the other environmental conditions like the velocity of flow, the settlement rate, etc. So that particles is remains throughout the same. So its size, shape and specific gravity will not change with the time. And what is the flocculating particles? The particles whose surface properties are such that They agglomerate upon the contact, thus the changing its size, shape, and perhaps the specific gravity with each contact. So the best example of both the type of particle is, so in primary sedimentation, all these particles are settled down by the force of gravity. That particles are discrete particles. And in secondary sedimentation tank, the whatever the dissolved particles present in secondary treatment process, that particles are forming the flock after adding the chemicals, and because of that chemical reaction, the size of particle, dissolved particle, will get changed. So it will basically converting the small size particle to the bigger size particles. So that means they are changing its property, and that particle are called as flocculating particles. So next is concentration of particles in suspension. So first is dilute suspension and second one is concentrated suspension. What is dilute suspension? Dilute suspension in which the concentration of particles is not sufficient to cause the significant displacement of water as they settle, or in which the particles will not be closed enough for velocity field interference to occur. That means the short circuiting will not occur in dilute suspension because the water is in dilute state, so it is not concentrated in nature. And in concentrated suspension, the suspension in which the concentration of particles is too great to meet the conditions maintained for the dilute suspension. So this is the tabular form. In that I just distribute all these properties of different types of particles, that is discrete particle and flocculent particles, and example, that table shows some example based on that particles. So discrete particles and flocculent particles I already described it. The settling of discrete particles in dilute suspension, the particles have no tendency to flocculate. They settle as individual entities and there is no significant interaction with the neighboring particles. That means all these particles are act as its individual nature. And in flocculent particles, the settling of flocculent particles in dilute suspension, as particles settle and cold sack with other particles, that means they are get attached with other particles, the size of particles and their settling velocities are increases. So example of discrete particles are removal of grit and sand in the wastewater treatment. An example of flocculent particles is in the removal of suspended solids in primary sedimentation tank of wastewater treatment plant settling of chemically coagulated waste sedimentation tank. So discrete particles are work under the force of gravity, and flocculent particles are worked on the mechanism of coagulation and flocculation to change its properties. So again in flocculent settling, the settling of intermediate concentration of flocculent particles. So again I told there are different type of flow, that is continuous flow and intermittent flow. So the particles are so close together that interparticle forces are able to hold them in a fixed position relative to each other, and mass of particles settle as a zone at a constant velocity. So example of such kind of intermittent concentration flow of particle is the biological flock removal in secondary sedimentation basin of wastewater treatment tank. And type 4 particles are compression settling. In compression settling, the force is the influencing factor is compression force. So settling of particles that are of such a high concentration that the particles touch each other, and settling can occur only by the compression force which takes place from the weight of particle. The example of such kind of particles are occurs in the bottom of deep secondary clarifier, in sludge thickening facilities. So because of the excuse me, because of the one layer is settled down onto the other, the third layer is settled onto the second layer. So because of its compressive force, all the particles are settled down by the force of compression. So the sedimentation tank can be divided into the 4 different functional zones. So as these terms I initially told that there are different zones in sedimentation tank. So what are the different zones? First is inlet zone, second one is settling zone, third one is sludge zone, and fourth one is outlet zone. So let's we see what are the meaning of each and every zone. So the inlet zone is occurs at this first one third or two third part of the sedimentation tank. So that is the inlet zone. The settling zone is happening in between the inlet and outlet zone. The sludge zone is at the bottom of the tank, and outlet zone is the influencing area is at the outlet of pipe. So let's we see what is the meaning of that zone. So first is inlet zone. This zone should disseminate the influence energy. It distributes the inflow, mitigating the density current, minimize the sludge blanket disturbances. Inlet structure are designed to uniformly distribute the influence suspension over the cross section of the settling zone. So main function of that inlet zone to distribute all this water uniformly. So basically the function of inlet zone is to maintain its velocity or uniformity. For rectangular basins, full width inlet channels, effective spreading of flow, introduce a vertical velocity component into the sludge happen that may resuspended sludge. Again, the inlet channels with submerged orifices for sedimentation tank followed by the flocculation in secondary sedimentation tank. In that the width of flocculation basin minus the width of settling tank. The depth of inlet channel is equal to the depth of flocculator basin and the pipe connections between the flocculation unit and sedimentation. The low velocity in pipe in case of secondary sedimentation in settling of floc and high velocity in pipe for breakage of floc. The permissible flow velocity to maintain the floc in suspension that is equal to 0.15 to 0.6 meter per second in case of secondary sedimentation in coagulation and flocculation process. So minimum velocity we are maintaining is 0.15 to 0.6 meter per second. If the sedimentation tank does not adjoin a flocculator, the inlet channel with submerged orifice do not extend down the full depth of the tank. In case of circular tank, the radial flow is maintained. To achieve the radial flow, the pattern's influence is introduced. So we already see that diagram, right? The diagram of inlet arrangement in case of circular tank. In the center of the tank or around the periphery of the tank center feed, the water enters a circular well designed to distribute the flow equally in all peripheral direction, and the D of feed well, that is the diameter of centrally placed vertical pipe, is 15 to 20% of the tank diameter. The depth of circular sedimentation tank maintained should be 1 to 2.5 meter, and the velocity through the orifices on feed well is maintained should be 0.075 to 0.15 meter per second. The entrance pipe suspended from the bridge or encased in correct beneath the tank floor. So these are some of the design criteria or parameters we are following during the design of sedimentation basin. The second zone is settling zone. In settling zone, it depends on the following design parameter. The settling characteristics of suspended matter, the surface loading or surface overflow rate, the width to length ratio or diameter, and detention time. Sludge zone. In rectangular tank, the bottom is slightly sloped to facilitate the sludge scraping. So generally we are providing some slope at the bottom of the tank. A pair of endless conveyor chain bridge type mechanism and continuously pulls the settled material into the sludge hopper where it is pumped out periodically. So its maintenance, regular maintenance is important. And the motion of scraper. The momentarily resuspended lighter particles a few centimeters above the scraper blades. An excessive horizontal velocity for the case of rectangular basins. So move these materials towards the outlet zone. So basically, Sludge zone, all these settled particles we are removing through the scraper, and all this clean water are moved to the last zone or outlet zone. So sludge zone is to prevent this. So to prevent the turbulence formation, so to prevent this, the horizontal velocity should be maintained as 9 meter per hour for the light flocculent suspension and 36 meter per hour for the heavier discrete suspension. Bridge type mechanism should be applied, travel up and down the tank, and one or more scraper blades are suspended from the bridge. So these are some criteria we should consider while the designing of sedimentation tank. Circular tank, the bottom of the tank is sloped to form an inverted cone, and the sludge is scraped to the relatively small hopper located near the center of the tank. The velocity or scraper is important, and very high velocity, that is resuspension of settled particles, should be happening to the velocity which is less than 5 mm per second. Traveling bridge with the sludge suction header and the pump, not very good. And last zone is the outlet zone. So weir channels are used at the peripheral area, outlet area of the circular sedimentation tank. The large weir loading is there. The resuspension of particles settled near the effluent launder. Launder channel means the peripheral channel. It is the formation of channel through that the clean water will get passed. The effluent weirs placed as far from the inlet as possible to increase the weir length, that is to decrease the weir loading. Double-sided weir can be used. So typical weir should be placed at 90° to the vertical V-notch metal plate bolted onto the effluent collection through the sedimentation tank. And it may be placed at the opposite end of the rectangular basins. So through the entire width of the tank, through the length of the tank, and if the weir loading causes the required weir length to be greater than tank width, the channel may be extended to the length of 1/3 the basin length. That means the dimension should be maintained properly. So its length should be always 3 times greater than its width of rectangular sedimentation tank. And around the perimeter of central feed circular tank, at the center of peripheral feed circular tank. So in case of a circular sedimentation tank, the inlet diameter of the inlet pipe is 20 to 30% of the overall diameter of tank. And in case of rectangular sedimentation tank, so length should be approximate 3 times greater than its width. So these are some design parameters that should we follow while the time of design of sedimentation tank. So detention period for plain sedimentation tank should be maintained approximately 4 to 8 hours. So that are also the important points. So sometimes they are asking as a MCQs in a MCQs types questionnaires. So what is the detention of plain sedimentation tank? That should be a 4 to 8 hours. And for the coagulated sedimentation tank, it should be reduced and it is approximately 3 to 4 hours. The second design parameter is velocity of flow. The velocity of flow is not greater than 30 centimeter per minute for the horizontal flow. The third important parameter is length to width ratio. So it should be 3 to 5:1. That means if your width is 1, then your length should be a 5. So generally length is equal to 30 meter. So common maximum up to the 100 meter. So we are placing the length of sedimentation tank maximum up to the 100 meter. The width is approximate, maintained should be 6 meter to 10 meter. In case of circular sedimentation tank, the diameter is not greater than 60 meter, generally kept as 20 to 40 meter, and depth should be kept as 2.5 to 5 meter. So generally we are adopted the depth of sedimentation tank is 3 meter. The surface overflow rate for the plain sedimentation, the surface overflow rate is 12,000 to 18,000 liter per discharge per meter square. So this is liter per day per meter square. So that is nothing but the velocity, flow velocity of water. So that should be a very high. So in plain sedimentation, the surface overflow rate should be maintained as 12,000 to 18,000 liter per day per meter square. Please remember this unit. So unit is in liter per day per meter square tank area, and for thoroughly flocculated water it should be again increased, that is equal to 24,000 to 3,000 liter per day per meter square tank area. And slope should be maintained for the rectangular sedimentation tank. It should be the 1% towards the inlet, and for the sedimentation circular tank it should be the 8% towards the central part or the inlet. The last parameter is detention period. The theoretical time required for given amount of the water or wastewater to pass through the tank at a given rate of flow. In other words, it is the average time for which the water is detained in tank. And how we are calculating this detention period? So there is a formula. So detention time is calculated by simply the ratio of volume to the flow rate. So what is the unit of volume in meter cube, and what is the unit of flow rate in meter cube per second or per hour? So ultimately the answer you will get into the second or hours or day. So in that way you are calculating the detention time, the volume divided by flow rate, and where T is the detention period and Q is the flow rate. So these are some of the design parameters. So if you want guys, then the problems based on that design parameter, we will see it in next lecture if you want. So put your comments into the chat box so I can see that. Okay, so one of the student is asked that circular or rectangular tank is good. So depending on its considering the which type of quality you will get out from this sedimentation tank. So economic point of view, circular tank is always better because it requires the less space compared to the rectangular tank. But again there are different parameters. What is the difference between plain and coagulated aided sedimentation? In plain sedimentation, we are not adding chemicals that we are adding in coagulation aided sedimentation tank. Plain sediment versus flocculate. Okay, I already explained that. What clear to kar do? Already I cleared that point, right? What is the difference between plain sedimentation and flocculated sedimentation? I already explained that. In plain sedimentation, simply by the action of gravitational force, we are settling all these particles, and in case of coagulated aided sedimentation, we are adding some chemicals so that we are changing the properties of dissolved particles. So we are increasing the size of particles, that is called as floc formation, and that floc we will settle down into the secondary sedimentation tank. So anyways guys, our time is over. So thank you so much for attending this lecture, and please put it your comment that if you want the more design problems based on that unit, then we will discuss it on our next lecture. So as the time is there, will be the time restrictions, we will stop here today's lecture. Thank you so much guys for attending this lecture. So bye all.